Hey everybody, this is Mrs. Ludis. Today's lesson is on functions. So one of the biggest thing with functions is the notation. Okay, so usually with functions, the actual math or algebra of it is not actually that challenging. It's knowing what the question is asking you that can get a little bit difficult. Okay, so for example, you'll see f of x, that's the way that we say that, f parentheses x. It's just another way to say y. Okay, and basically if I'm finding f of something, that means to plug that number into the function. Okay, so for example, the first one is pretty simple. It gives us a function, let f of x equal x minus 7, compute f of 16. All that means is every time I see an x, instead I'm going to replace it with 16. So again, the math of that is not that challenging, right? I plug in 16 and I see what I get back out. That's it. Okay, but if you don't know what this means, then that problem can be a little confusing, right? Okay, so 16 minus 7 is 9, so that would just be my answer. Okay. Second one gives us two different functions. Let f of x be x minus 7, g of x is x squared minus 3. Okay, now h of x is f of x plus g of x. Okay, so, and we want to find h of 1. Okay, so basically this is telling me I'm going to add my functions together after I input 1. Okay, so what I'm going to do is I'm going to plug 1 into the f function, then I'm going to plug 1 into the g function, and then I'm going to add those two numbers together. Okay, so let's do that. F of 1 is 1 minus 7, which is negative 6. G of 1 is 1 squared minus 3. 1 minus 3 is negative 2. And this is telling me to add those functions together. So negative 6 plus negative 2 is negative 8. Another way that you could have done that problem, which I think is a little bit more work, is to add those functions together, like add these together, combine your like terms, and then plug 1 into that function. You'll get the same thing. I think it takes a little bit longer, but that's sometimes a personal preference. Okay, and I should also mention, just a reminder that as we're going through these video lessons, if you want to stop the video and try some on your own before you hear me go through them, that's probably a good idea. Maybe even stop it now, see if there's any problems you think you could do right now on your own, and then go back and listen to the explanation and see if you got it right. Okay. Example 3 gives us two functions again. F of x is x squared plus 1, g of x is x plus 2. Now, this is probably a little confusing to you. Okay, this is a composition. It's a function within a function. Okay, so the way you would say that is f of g of 2. And the biggest thing to remember with compositions is to work inside out. So the first thing that I'm going to do is I'm going to calculate g of 2. Okay, so here's my g function. I'm going to plug in 2 for x. So that's simply 2 plus 2, which is 4. Okay, so this right here is 4. So now you can see if my inside function is 4, now that is what's going to go into my outside function. Okay, so I calculate a function, and then whatever I get there goes into the other one. Okay, so now I go to my f function, and I plug in 4. So f of 4 is 4 squared plus 1. 16 plus 1 is 17. So that's my answer. Okay, again, it's a function within a function, which is also going to be seen in example 4. Okay, so here instead of giving you the function itself, it's giving you a table of function values. Okay, so all of your x values are your inputs. Okay, so basically they plugged these values in and they got the resulting values out from f and from g. Okay, so we're going to use this table to find g of f of negative 1. Okay, so keeping in mind what we talked about last time, we're going to start with the innermost function, f of negative 1. Okay, so I go to my table, I find negative 1, and it looks like if I plug negative 1 into the f function, I get out negative 2. Okay, so remember, if this is negative 2, that then is going to go into my other function. So now I'm finding g of negative 2. So I find negative 2 in the x column. It looks like if I plug negative 2 in for x to the g function, I get out -3. Okay, so that time it's not actually any algebra that you need to do. It's just reading a table and understanding what a composition is. All right, number 5 is kind of interesting. Okay, so this table here, it's saying that it's representing an exponential function. Okay, so that's where we have a variable in the exponent. Okay, which of the following is the function that it represents? So the first thing I'm going to focus on is the fact that they told me it was an exponential function. Okay, so right away, A is exponential, so it could be this one. B is a quadratic, so I automatically know that B is not my answer. C is exponential. Okay, I know that because both of these have an x in the exponent. Okay, and then D is a linear function. That's not exponential. So now I'm down to these two, the ones that I have highlighted, A and C. Okay, so all I'm going to do is I know that 0, 3 is a point on that function. So what I'm going to do is I'm going to plug in 0, 3. And I'm going to see which one of these functions it works for. Okay, so if I plug in 0 for x and 3 for y, I would get 3 equals 3 times 2 to the 0. Okay, so let's see if that's correct. 2 to the 0 is 1. 3 times 1 is 3. Okay, so I end up with a true statement there, which means A is going to be my answer. You can see here if I flip that, so if I plug in 0, 3 here, I would have 3 equals 2 times 3 to the 0. This would say that 3 equals 2, which is not true, which is how I know that C does not define that function. Okay, so that one I just used some guess and check once I eliminated 2 of the options that I knew it couldn't be. Okay? Next one, the table shows some values for f and g. It's kind of similar to what we did with a couple problems ago. For which value is f of x minus g of x equal to x? So this is kind of interesting. Okay, so I'm looking at the y value from f of x. I'm going to subtract the g value, and then which one does it equal the input? So output minus output equals input. Okay, so I'm just going to do guess and check on this one. Okay, so I'm going to go look here for when x is 2. That's this row. Okay, so they said f minus g. So that would be negative, that would be negative 1 minus 3, which does not equal 2. Okay, so it's not A. Now let's see what happens when x is 3. Okay, so that's going to be this row. F minus g is 2 minus negative 4, which is 6, not 3. Or here, it doesn't equal 3. Okay, so it's not B. Let's try when x is 4. Okay, when x is 4, f minus g is 9 minus 5, which does equal 4. Okay, so these are equal, which means it's C. Okay, and it's kind of interesting. Again, the math of that is not hard, you guys. It's just kind of knowing where to start and what that notation means. Okay. Next example. Some values of a linear function, okay, linear, are shown in the table below. Which of the following defines f? Okay, so this is kind of like what we did with the exponential. Now, the problem with this one is when I look at those functions, all 4 of them are linear. So I can't actually eliminate any just based off of the type of function that they are. Okay, so I am simply going to plug in values. Okay, so I'm going to start with 2, 3. And I'm going to see if it works in these functions. Okay, so again, maybe not the most time effective way, but it works. Okay, so it's going to be 9 halves times 2 minus 6. Okay, that's going to be 9 minus 6, which does give me 3 as an output. So far it could be A. Okay, it's only 1 point though, so I need to make sure they don't work in any of the other ones. Okay, so 2/9 times 2 plus 4/3. That's going to be 4/9 plus 4/3, which is not going to give me a nice answer, so it's not going to be B. okay? This one, 9 times 2 plus 2, that's 18 plus 2, which is 20, not 3. Okay, so let's see if we can get away with just checking 1. So 9 times 2 minus 15 is 18 minus 15, which, is 3. Okay, so now we're down to these two. So now I'm just going to move on and also check the next point. I'm going to check 412. Okay, if I plug that in the first one, 9 halves times 4 minus 6, that is going to be 36 over 2 is 18 minus 6, which is 12. Okay, so double check mark there. Let's see if D also works. So let's see, 9 times 4 is 36, minus 15 is, 36 minus 15 is 21, not 12, which means it's not D. Okay, I'm going to be really honest. I don't have a really great way other than guess and check for number 2, but it wasn't too bad. Okay, a couple left here. A function P satisfies these things. Okay, so if I plug 1 into P, I get 4. If I plug 4 into P, I get 6. Okay, further, a function Q satisfies. Okay, if I plug 4 into Q, I get 1. If I plug 6 into Q, I get 7. Okay, so I have some inputs and some outputs. What is the value of P of Q of 4? Here's another one of those compositions. The SAT loves compositions. Okay, so let's start with the innermost function. Q of 4. So let's go back to what they told me over here. It told me that Q of 4 is 1. So this is 1. Okay, so if Q of 4 is 1, that was my innermost function. And now I'm taking that 1 and plugging it into P, which if I look over here, it told me that P of 1 is 4. So my answer is simply 4. Okay, no math needed. I'm just reading the inputs and the outputs and understanding what that function notation means. Okay, last one is another composition. Okay, it gives me two functions and it wants me to find g of f of -1. Okay, so again, starting with the innermost function. Okay, I'm going to go to the f function and plug in -1. Which is going to be -1 plus 3, which is 2. Okay, so this is 2. So now I'm taking that 2 and I'm plugging it into the g function. Okay, so g of 2 is 2 squared minus 1. That's 4 minus 1, which is 3. That's it. Okay, so this was a grid in here, so let's practice that. I'll put my 3 either at the beginning or at the end, and then bubble that 3. All right, that's it for that lesson, you guys. Okay, hopefully you feel a little bit more comfortable with that function notation. Reminder, all of our teachers are ready and waiting to help you if you're having any questions. Okay, first half of any of the 4 lunch periods, feel free to join our Zoom and get anything cleared up, okay? Have a great day.